On high demand from worldwide, theory of hypothesis testing will be done in 3 parts by Professor Dr. Amarendra Mishra.
In my last talk, I discussed that test would certainly be the best test in which the probabilities of the 2 types of error are at minimum possible level. But for fixed sample size, there is one difficulty in it. We cannot minimize the probabilities of both the errors at the same time. If we try to minimize the probability of type 1 error, the probability of type 2 error gets automatically increased. And vice versa. It acts like this. Suppose that this is type 1 error and this is type 2 error. If we try to minimize the probability of type 1 error, the probability of type 2 error starts increasing. If we try to minimize the probability of type 2 error, the probability of type 1 error starts increasing. So these 2 types of error act like this. Have you seen in children's park, we call that seesaw, that is a wooden bar or a rod bar. At one end one child sits and at the other end another child sits. If this child pushes down, this child goes up. When this child pushes himself down, this child goes up. So suppose that on that bar at one end, the probability of type 1 error alpha is sitting, and on the other end, the probability of type 2 error beta is sitting. If alpha is pushing down, beta goes up. If beta pushes down, alpha goes up. So it is like seesaw. I would like to give one practical example which may help us in understanding this phenomenon clearly. Suppose one day your office boss calls you and asks you to go to the market and purchase some stationery articles for the office use. And at the same time, he gives you a stern warning that if even a single article would be found defective, you would be severely punished for that. Obviously, the warning of your boss would make you more sensitive towards the error of purchasing a defective article, which is equivalent to accepting a false hypothesis, that is type 2 error. You would become oversensitive that no defective article is purchased, and in that way, if you would have a little doubt in any article, you would like to reject that article. Because the warning of your boss is haunting in your mind. No defective article should be purchased. No defective article should be purchased. No defective article should be purchased. You have become overcautious about type 2 error. No false hypothesis should be accepted. So what would happen? If you find a little doubt in any article, you will find it to be on the safe side to reject that article. But don't you think that by doing this, the probability of type 1 error, that is the probability of rejecting a non-defective article, that is equivalent to the probability of rejecting a true hypothesis, has increased? So whenever you try to minimize the probability of one type of error, the probability of the other type of error automatically gets increased. Let me give you another example. Suppose there is a judge, and the judge is of this view that no innocent person should be convicted. So he is very cautious about it, that no innocent person should be convicted. He has become more sensitive towards this error, that no innocent person should be convicted. Now, don't you think that in this case, in lack of sufficient evidence, the chance that a culprit is acquitted would increase? This is another type of error. So when you are trying to minimize the probability of one type of error, the probability of other type of error automatically increases. When we become overcautious about one type of error, the other type of error increases. This generally happens. So this is the problem. The problem is that we have to find that test in which the probabilities of both types of error are at minimum level, but at the same time this is also true that we can't minimize simultaneously the probability of the two types of error. So how to manage this situation? How to deal with this situation? There is one way out, and that is that when both the probabilities alpha and beta are acting like this, let us do one thing. Let us prefix the probability of one type of error at certain level. We will decide in the beginning that this much error of this type we are going to do. And then for that prefixed level of that type of error, we try to minimize the probability of the other type of error. So if the two types of error are acting like this, moving like this, you fix one type of error, fix it. Fix it with a nut and bolt. There would be no movement in it. And then try to minimize the probability of the other type of error at the minimum possible level. This only we can do to manage such situation. And this is what we do in testing of hypothesis. We prefix the probability of one type of error, and then we try to minimize the probability of the other type of error. Now a question arises here. Which type of error should be prefixed? Which type of error should be minimized? We may fix the probability of type 1 error at certain level, and then we may minimize the probability of the other type of error. Or we may fix the probability of type 2 error at certain level, and we may minimize the probability of type 1 errors. In Neyman-Pearson theory of hypothesis testing, we prefix the probability of type 1 error. And for that prefixed level of probability of type 1 error, we try to minimize the probability of type 2 error. So in the beginning, before applying the test, we fix it that alpha, the probability of type 1 error, would be this much. Generally, we take it 0.05 or 0.015% or 1%. Suppose that we have fixed alpha at 5% level. What does it mean? It means that we have agreed to commit type 1 error in 5% of cases. Alpha is equal to 0.05. And then we minimize the probability of type 2 error, that is beta. This is what we do in testing of hypothesis. One may ask that why we prefix the probability of type 1 error and minimize the probability of type 2 error. Why not we do it other way? Why not we prefix the probability of type 2 error, that is beta, and minimize the probability of type 1 error, that is alpha. The reason behind this is that generally, I am not saying in all cases, generally, type 2 error is considered to be more dangerous than type 1 error. I will give you one example. Why I am saying like this? Why type 2 error is considered more dangerous, more serious than type 1 error? Now let us think it in this way. What is type 2 error? Type 2 error is acceptance of a false hypothesis. Now suppose that you have committed type 2 error. You have accepted a false hypothesis. That is, you have assumed that hypothesis as true hypothesis which is really false. Now all your future planning would depend upon this. all future planning will be done assuming that this false hypothesis is true. Now you think how dangerous it would be. Your whole planning is based on false, you may say false base. The whole planning will collapse. But if we do type 1 error, that is, if we are rejecting a true hypothesis, yes, we are doing error. This is also error. But it is not that much dangerous as type 2 error. Let me give you one concrete example. Suppose that the construction work of a bridge is going on. In that bridge, suppose some iron rods are required, which are generally required. So iron rods are required, iron beams are required of some specified tensile strength. Now we have placed the order to the company to supply the iron beams of that specified tensile strength. The company will deliver the iron beams at the site of the bridge construction. Now it will be the duty, it will be the work, it will be the task of the quality control engineers to test or to confirm whether the supplied iron beams are of the specified tensile strength or not. Now suppose that in testing this hypothesis that the iron beams are of the specified tensile strength. Suppose in testing of this, the engineers have committed type 1 error. Means that they have rejected those iron beams which they shouldn't have. They have committed type 1 error. They have rejected a true hypothesis. What would be the case? Those iron rods, iron beams would not be used in the bridge. The company would be asked to take away those iron beams. At worst, the company would be in some loss. But think of the other situation. If the quality control engineers in testing this hypothesis have committed type 2 error, that is, they have accepted those iron beams which are not of the specified tensile strength, that is, they have accepted a false hypothesis, they have accepted that hypothesis which they should have rejected. Now what would happen in this case? Those iron beams would be used, those iron beams which are actually not of the specified tensile strength. Those iron beams would be used in the bridge. What would be the result? the bridge will collapse. Many people will die. It would be disastrous. So, in this sense, I said that generally type 2 error becomes more dangerous. Sometimes it becomes disastrous. Let me give you another example. Suppose that there is a drug, medicine. So many constituents are there. One of the constituents of that drug is poisonous. Now we have to test whether that constituent which is applied, which is in the drug, is of the prescribed level or not. If that constituent is more than the prescribed level, then the drug would be fatal. Now, we will do hypothesis testing here. Whether that constituent of the drug is of the specified level or not. Suppose that drug, that constituent in that drug is not more than the specified level, but we have done type 1 error here. We have found after applying our test that that drug is more than the specified level. We will reject the hypothesis. We will not allow that drug to go in market. What would be the worst case in this situation? The worst case would be that the company would be in loss due to our error, type 1 error. But think of the other error. If we commit type 2 error here, that is, if that constituent is applied more than the specified level in that drug, and we have accepted that one, we have accepted that drug which we should have rejected. We have committed type 2 error. We have accepted a false hypothesis here. What would be the result? The drug will be fatal, many people will die. Which one is more serious in this situation? Type 1 error or type 2 error? Certainly type 2 error. So, generally I am saying, not in all cases, but generally type 2 error is considered to be more serious than type 1 error. And this is why we try to minimize the probability of type 2 error as possible as we can for a fixed, prefixed level of the probability of type 1 error. There may be situations where type 1 error may be considered to be more dangerous than type 2 error. We can have some situations like that. But the theory of hypothesis testing, which is mainly due to Neiman and Pearson, we do this one. We prefix the probability of type 1 error, that is, we prefix the value of alpha, and for that prefixed value of alpha, we try to minimize the probability of type 2 error, that is the value of beta. This is what we do in hypothesis testing. So, this is the logic behind hypothesis testing. This is the philosophy behind hypothesis testing. Now, next we would talk on some other topic. Thank you very much. Thank you.